here we have a pre-weighed pear-shaped flask. Into the flask we're going to put 5 mils of 2 molar sulfuric acid and 0.24 grams of iron 2-sulfate heptahydrate. Just making sure all that's in. Now we swirl the flask to make sure the iron sulfate dissolves. There we are. We're now going to reweigh the flask and then add 1 centimetre cubed of butan-1-ol. So off camera, just weighing the flask there. It is in fact 40.935 grams. So to the flask that's just been weighed, we're going to add 1 centimetre cubed of butan-1-ol and reweigh the flask. Now, I've added the butan-1-ol with care, and you may just be able to see that the butan-1-ol is in fact immiscible with the sulfuric acid. It has a solubility of about 7.3 grams per 100 centimetres cubed of water, and it's not dissolving there, not fully. It's a layer on the top, but we'll weigh it anyway. And that's now 41.679. Well, the next thing to do is just to add a couple of anti-bumping granules to assist boiling. So in they go. Move the reagents out of the way, and the last thing we add before attaching to the micro-distillation apparatus here is 12 mils of 6% hydrogen peroxide solution. That's approximately equivalent to 20 volume hydrogen peroxide, and we have that prepared here. Now, once we add the hydrogen peroxide, what usually happens is the increase in volume of the aqueous phase is such that the butan-1-ol, which is on a surface layer here, a separate layer, then dissolves. So we carefully add that. There's the hydrogen peroxide. You might see some yellow coloration due to a change in the oxidation state of the iron. And indeed we have now dissolved all of the butan-1-ol that was on the surface layer. Well, what we need to do now is to connect the pear-shaped flask to the micro-distillation apparatus. Just trap the seal, make sure we get the seal right there. It's all in vain. Just check those. So what we're now going to do is we're going to heat the pear-shaped flask here gently with the Bunsen burner. The reaction is exothermic. It's a Fenton's oxidation system, but it needs a bit of heat to get it going, otherwise we'll be waiting for rather a long time. So we'll gently heat that with a Bunsen until it starts going, and note the temperature increase. The temperature at the moment is at 28.5 degrees centigrade, and we'll hopefully drive over any oxidation product. You will of course remember, if you make an aldehyde from an alcohol, you want to immediately distill it so it doesn't oxidize any further to the carboxylic acid. So let's just add a little bit of heat to the system here. Now you can heat with boiling water bath, but it tends to be rather slower to get started doing that. And not only that, it's somewhat less predictable. With the Bunsen burner, if we want to add any extra heat, it's very easy. Now what we're looking for are some bubbles of gas, presumably oxygen, as the hydrogen peroxide starts to decompose, but as of yet, nothing. So you may be able to detect some slight bubbling in the flask there. There are a few bubbles at the bottom. They're very small. And we're hoping for something a bit more vigorous than that. Now, you can probably see some boiling at the top of the flask. And the temperature has risen now. It's at 50. It's rising rapidly, 55, 60, 65, 70, 75, this indicating the exothermic nature of the reaction, 80, and we've just hit 85, 86, going up slightly. We want, of course, some product to distill over. The product's around here at the moment, you can see it. We're at 90 degrees now. I just want to tilt that a little bit to encourage any product to come down. The temperature has reached 93, and you can start to see material distilling over and dropping off into the collection tube that we've got surrounded by ice. And the temperature is leveled off at 96 degrees centigrade. We've got some darkening of the reaction flask here, and you can see there's no need to apply any more heat as the reaction is exothermic. The temperature creeping up now to 97.5, almost touching 98. And levelling off at 98 when we've got quite a vigorous reaction there. Well, we'll allow that to continue so that we collect at least 2 mils of distillate, remembering that we put 1 mil of butan-1-ol in initially. And the temperature now falling, it's now back to 96.5. We need to check how much distillate we've got. And I can see down in there, we've got about half a mil to a mil. Maybe not quite enough, so we can always apply a little more heat to distill over some of the mixture. And as you can see, only very little heat needs to be applied, and such is the nature of the reaction, it gets going again very rapidly indeed. Temperature holding at 96.5. Okay, we'll see you in part 2 of this oxidation reaction.